Welcome to Learning to Engineer. How much high voltage is high voltage for you? If I ask this to a circuit component designing person or a PCB design person, they'll be telling something around 1 volt. Because for circuit design, hardly few millivolts and microvolts of voltage will be used there. But if you ask a HVAC person, he'll be telling something around 50 volts to be high voltage. The same if you have asked to a power generation person or someone who is working in the transmission line, in the substations, in nuclear power plants, they'll be telling high voltage to be something in few kilovolts or even megavolts. So the definition of high is different in different contexts. According to the NEMA standards of US, a high voltage is considered to be a voltage that is between 100 to 230 kilovolts. But according to British standards, it's something between 1000 to 1500 volts. But in India, we say any voltage above 1000 to be high voltage. So the definition of high voltage is different in different standards. In my video, in this particular one especially, I define high voltage to be something that is used for power generation and power transmission purposes, which is something more than 1 kilovolt. In this video, you will have a detailed video on how the substation work and the different components that are there in a substation. I highly recommend you to watch that and jump right here. The rating of a device has to be chosen based on the application where it is required. I'll give you an activity. Go to the nearest transformer that is there near your home. Whenever you go to that side, you can just have a look at the nameplate of the transformer and find out the rating of that transformer. You'll be surprised to know. The transformers are available in different ratings, right from 12 volt, which is used in small applications, till 2400 volt or 5000 volt. You have transformers available. You can just go to the nearest transformer that is available and check out the nameplate of it. You will be able to see the rating of that transformer. So basically, depending on the rating of the transformer, it is constructed in such a manner to hold up to that voltage. For a transformer which is small in the sense 12 or 24 volt transformer, the surface will be smooth and it will be airtight, because you don't have any special cooling requirement for that. For a 12 volt, just air cooling is enough, or natural way of cooling is sufficient. But for higher ranges of voltages, you need to supply a oil so that the transformer gets cooled correspondingly. And even in high voltage circuit breakers, you have forced oil cooling, vacuum cooling, and there are different cooling mechanisms in circuit breakers as well. In a small transformer, the surface or the tank surface will be airtight. But in a higher rating transformer, there will be some gap left between the transformer and the oil, because due to heating, the oil will expand and it needs to flow into the transformer so that it doesn't leak outside. The oil itself will be something around 1000 to 1500 kgs. I'm not joking, because the rating will be something like 100 kilovolt to 250 kilovolt. For such ratings, the oil will be 1000 kgs to 1500 kgs of oil will be there inside that transformer. It's very heavy and it doesn't have to be airtight in that case. So based on the voltage rating, the transformer's design will totally vary. So there are differences in the construction of the transformer as well. Let's talk about circuit breaker. What is a circuit breaker? A circuit breaker is a device which will isolate the circuit or which will break the circuit when there is abnormalities in the current. For a higher voltage ranges, the circuit breaker size will be huge and it will be elevated from the ground. It will not be there at ground location. If you get a chance, please browse for videos on circuit breaker operation in a substation. You will be surprised to see the way they switch on and switch off the circuit breaker. In the circuit breaker that you see in your home or in light industries, it is just hand operated and manually operated. But in heavy industries, the size of circuit breaker is huge and it will be elevated from the ground. It will not be at ground level. Even the isolator, disconnector switches, everything will be elevated from the ground so that the heating doesn't affect the people who are nearby. So how will they operate that circuit breaker? you will be able to find a lever that is there, and they will be manually pushing and pulling that lever in order to open and close the circuit breaker. Just have a look at that video as well, so that you get a better idea of how the circuit breakers are operated. If you are an engineering student, I highly recommend you to go for an industrial visit to a substation or any power transmission place, so that you get an idea about the size of the circuit breaker and how it is operated. Even the circuit breakers will have some specialized fin and oil cooling for arcing system to generate heat, and the heat will be absorbed by the coolant which is there inside the circuit breaker. Basically, there are two kinds of oil circuit breakers. There will be a moving contact at the bottom and a fixed contact at the top. What is moving contact? If you had watched this video, you will be able to answer that. Due to abnormal cases and due to abnormal scenarios, by electromagnetic induction, the contact will be moved apart to break the circuit. This is a moving contact. And when this happens, when you are trying to break 4000 volts, imagine the heat that is getting produced in that circuit breaker. It will be huge, right? So in the gap between the fixed and the moving contacts, there will be some space where arcing happens. When you have oil immersed into this area, there will be a hydrogen bubble that is forming on either sides of the bushings. So this hydrogen bubble will be absorbing all the excess electrons, and the oil will be cooling down the heat that is generated in this process. That is why we have specialized arrangement to absorb the heat. Unless we do this, the circuit breaker will blast, and there will be other safety issues in this as well. So now you might know why do we use specialized components for high voltages. Even the electricians, they have specialized work permits for that. An electrician who is permitted for HVAC applications will not be permitted for higher voltage engineering purposes, because for a HVAC person, he is allowed to only operate on 50 or less than 50 volts. But for a person who is authorized to operate on higher voltages, the safety standards will differ. His even mode of training and the way he operates the circuit breaker will differ. There are so many types of circuit breakers, you will be very amazed to know. So even the electrical permits are classified according to the voltage ranges. For a high voltage circuit breaker, you have oil filled type, vacuum type, SF6, and nowadays they are even using CF3 gas instead of SF6. I hope you all had watched this video where I had talked about the operation of SF6 circuit breaker. In a SF6 circuit breaker, when the moving contact and the fixed contacts gets separated due to any arcing or any current faults or something, SF6 gas will be pumped into the arcing chamber to minimize the electrons that are spilled. Nowadays, we are using CF3, carbon trifluoride, instead of SF6, because CF3 is a greenhouse gas. It doesn't affect the atmosphere. So, why to use SF6 in that case? SF6 is very electronegative. You have so much advantages because of that. But when you use CF3, it is another plus point that it is friendly to environment as well. So they have started using CF3 in the place of SF6. So depending on your application, you have to choose the component that is desirable for you. It might be a circuit breaker, it might be an isolator, a transformer, or any other device. The cooling conditions and the way the air is circulated and the way the excess electrons is absorbed, everything differs based on the working current of that application. So I highly recommend you to go to a substation to watch how a circuit breaker is put on and put off. It will be a really good experience for you as well. Thank you.